Here's the solution to Calc 3, exam 4, the 5 o'clock section. In number 1, we have x equals 0, x equals 1, x equals 2, y equals 0, y equals 1, y equals 2, y equals 3. So your delta A is very conveniently 1 by 1 squares. And here are the midpoints, 0.5, 0.5, 1.5, 0.5, 0.5, 1.5, 1.5, 1.5, 0.5, 2.5, 1.5, 2.5. Okay, so the double integral over the region of 6x plus 2y dA is approximately delta A, which is 1. And then the function value at all the midpoints. So f of 0.5, 0.5, f of 1.5, 0.5, f of 0.5, 1.5, f of 1.5, 1.5, f of 0.5, 2.5, and f of 1.5, 2.5. And so you plug all of these into 6x plus 2y, you get 4 plus 10 plus 6 plus 12 plus 8 plus 14 times 1. Answer is 54. Number 2, integral of cosine y is sine y. So sine x, sine y, y goes from 0 to pi over 2. Plug in pi over 2, you get 1. Plug in 0, you get 0. So you're integrating 1, which means you can just take it all the way out. Integral of sine is negative cosine from 0 to pi over 2. So negative cosine pi over 2 is 0. Cosine of 0 is 1. So the negative of negative 1, the answer is 1. Number 3, integral with respect to y, 5xy minus y squared. Y equals 0 to x squared. Plug in 0, you get 0. Plug in x squared, you have 5x cubed minus x to the 4th. So when I integrate, that's 5x to the 4th over 4 minus x to the 5th over 5 from 0 to 1. Plug in 0, you get 0. Plug in 1, you have 5 fourths minus 1/5, which is 25 over 20 minus 4 over 20, 21 over 20. Number 4, 0, 2, 1, 1, 3, 2. This has a slope of negative 1. So y equals negative x plus 2. Solve for x. X is 2 minus y. Here the slope is 1/2 y minus y1, 1, equals 1/2 x minus 1. Solve for x. Multiply by 2. Add 1. X is 2y minus 1. So I'm treating this as type 2. Lower function, upper function. If I tried the conventional type 1, you'd have to break it up into 2 pieces because the lower function changes through part of the problem. So I have to use this function and then this function. But here the lower function is always this line, 2 minus y, and the upper is always 2y minus 1. So it's better to integrate with respect to y. So double integral, x goes from the lower 2 minus y to 2y minus 1, and then y goes from 1 to 2 of y dx dy. Y is a constant as far as x is concerned, so I just have to put the length of the interval. So y times 2y minus 1 minus parentheses 2 minus y dy. This comes out to be 3y minus 3. Distribute 3y squared minus 3y, whose integral is y cubed minus 3y squared over 2 from 1 to 2. Plug in 2, you have 8 minus 6, minus plug in 1, 1 minus 3 halves. So it's 2 minus 1 plus 3 halves. Final answer is 5 halves. Number 5, you're integrating y, which is r sine theta, and then r dr d theta. That's going to become r squared. R is going from 0 to 7. Theta is going from 0 to 2 pi. So I'm integrating r squared sine theta with respect to r. That's r cubed over 3 sine theta. R goes from 0 to 7. Plug in 0, you get 0. Plug in 7. 7 cubed is 343. So I have 343 over 3. Integral from 0 to 2 pi of sine of theta. Integral of sine is negative cosine. So negative 343 cosine of theta. Cosine of 2 pi is 1. Cosine of 0 is also 1. So the final answer is 0. Number 6, the picture looks like this. X is going from negative 1 to 1. Y is going from 0 to radical 1 minus x squared. That's my unit circle, half of it. So theta goes from 0 to pi. R goes from 0 to 1. Of e to the x squared plus y squared is e to the r squared, r dr d theta. This integral does not depend on theta, so just take out the pi. I am going to multiply inside by 2 and outside by half. That way you have the u substitution set up, e to the r squared times 2r dr. But rather than actually doing a u substitution, just integrate pi over 2 e to the r squared from 0 to 1. And by the way, you can always double check by saying what's the derivative of e to the r squared? E to the r squared times 2r. Okay, so pi over 2, plug in 1, you get e. Plug in 0, you get 1. So final answer is pi over 2, e minus 1. Okay, number 7, the inside integral 2x dy, this doesn't depend on y. So again, I just have to put the length of the interval, which is x plus z. So it's 2xz times x plus z. Distribute, you get 2x squared z plus 2xz squared. Integrate with respect to x. That's 2x cubed over 3z plus x squared, z squared. X goes from 0 to z. Plug in 0, you get 0. Plug in z, you get 2z to the 4th over 3 plus 2z to the 4th. So dz, integrate with respect to z, that's 2z to the 5th over 5 times 3 plus 2z to the 5th over 5 from 0 to 1. Plug in 0, you get 0. Plug in 1, 2/15 plus 3/15, so 5/15. So final answer should be 1/3. Okay, number 8, 300,020,001. Okay, so I set ax plus by plus cz equal to the least common multiple of 1, 2, and 3, which is 6. Then I plug in. So plug in 0 for y and z, and 3 for x. That means a is 2. Plug in 0, 2, 0. So put a 0 here, and 2 for y. 2b is 6. That means b is 3. And 0, 0, 1, put a 0 here, 0 here, 1 here. That means c is equal to 6. So the equation of the plane is 2x plus 3y plus 6z equals 6. Solve for z. 6 minus 2x minus 3y over 6, or 1 minus 1/3 x minus a half y. So z is going to go from 0 to 1 minus 1/3 x minus a half y. Now in the xy plane, just take 0, 2, and 3, 0. The slope is negative 2/3. Y-intercept is 2, so y equals negative 2/3 x plus 2. By the way, you can double check. Plug in 3, you get 0. Plug in 0, you get 2. So y goes from 0 to negative 2/3 x plus 2, and then x goes from 0 to 3. Number 9, the square root of x squared plus y squared, that's the square root of r squared, which is r. So I'm integrating r, and then times another r, dz, dr, d theta. Z is going from negative 1 to 4. R is going from 0 to 6. Theta is going from 0 to 2 pi. This stuff does not depend on theta, take it out, 2 pi. This stuff does not depend on z, take it out. The length of the interval is 4 minus a negative 1, 5. And the only thing I have to integrate is r squared. So I have 10 pi, r cubed over 3 from 0 to 6. Plug in 6, you get 72. So 10 pi times 72, 720 pi. Finally, number 10. X squared plus y squared plus z squared is rho squared. Okay, so rho squared times rho squared sine phi, d rho, d theta, d phi. Phi goes from 0 to 3. Theta is going from 0 to 2 pi. And remember, phi does not go from 0 to 2 pi. It's just enough to go 0 to pi for phi. So if you're starting up here, you go down to pi. You've already reached all you need. You don't have to keep going because it was already covered on the other side around. So phi is only going from 0 to pi. Okay, this integral does not depend on theta. Take out theta, 2 pi. Rho squared, so rho to the 4th sine phi. Integrate with respect to rho, that's rho to the 5th over 5. Sine phi from 0 to 3. Plug in 0, you get 0. Plug in 3, 2 pi times 243 over 5. Integrate sine phi, d phi from 0 to pi. So that comes out to be 486 pi. Integral of sine is negative cosine from 0 to pi. So negative 486 over pi over 5. Plug in pi, you get negative 1. Minus plug in 0, you get 1. 972 pi over 5. All right, so these are solutions to exam 4 for top 3, 5 o'clock section.